mentioned, I'm working as an architect for Trifork, which means I help a lot of customers to build a diversity of custom enterprise applications. And in an increasing amount, a lot of those applications are not built as a single monolithic artifact anymore, but are split up in a multitude of deployable components. This basically brings us to the topic of microservices. Now, in this webinar, I very much want to focus on explaining what you can do in a practical setting with the Spring Cloud and Netflix setting, but a little bit of background might help to understand why you might actually want to apply those projects. So on the one hand, obviously companies like Netflix, who pretty much define what it means to be web scale nowadays, they have the need for an architecture that will support a huge amount of end users and requests to be handled, and also to be able to scale up and down in a very easy way, given the peak loads that they have. That is definitely one obvious use case, I think, for using microservices. Personally, as an architect for Trifork, what I find as well is that another important reason is not so much the operational scale as the development scaling of how you build a project or a product actually. What you often find is that when companies start building a product, it will be built as a single application, and that will be fine for a while. But as the team grows and as the functionality grows and as more and more aspects need to be covered, it doesn't really scale that well anymore to do everything in a single team working on a single product, and you want to split things up so they can have their own life cycles, they can have their own teams also developing these applications. And if you then also want to do things like reuse, it often makes sense to migrate towards a microservices-based architecture, and that's very much the stage that we are currently in as well with a lot of the projects and products that we are involved in. And as you are migrating to such an architecture, you are basically starting to build distributed systems, and you should not underestimate what it actually means to migrate from a single application where everything happens in memory, every call is just a call to a local object, compared to making calls across a network to other services where you don't know where the services are, you have to look them up, you don't know if those services are at that moment actually available, you need to be able to deal with problems that services or that the network itself may have, and so on and so on. And this is not something that you only need to tackle at an operational level. It's also something that will affect the architecture of the systems that you're building yourself. All right, so that means that this is something you need to be prepared for. Also, what it means, for example, is that many more things than in a traditional monolithic application will need to be automated. Not only will your builds and running your tests and that sort of thing need to be automated, but basically you need to have a whole deployment pipeline where things like testing and promotion of applications and eventually deploying to production becomes a push-button process, and where also the monitoring and if you need elasticity in cases of peak loads and that sort of thing, also spinning up and down certain instances is something that can happen in an automated fashion, where you don't need to manually take care of all of these things, right? So that means that as you are moving towards an architecture that has more, well, not necessarily microservices, but at least individually deployed services that cooperate as a single platform, you need to take care of certain things, hence the no free lunch that you see here. There's actually a lot of good information out on the web on some of the problems that you will face as you are starting to do this, and free lunch and microservices is actually a pretty good term to Google if you're interested in more on those topics. Now, this means, as we are facing new problems, that new solutions are surfacing, and starting from the infrastructure level, something that hopefully all of you will have heard of at least by now is Docker, for example. Docker is a container solution which allows you to build your applications in relative, or run your applications, I should say, in relative isolation from each other. It will appear to the applications that they have their own machine that they're running on, their own memory space, their own file system, that sort of thing. But you can actually utilize the underlying hardware very efficiently, much more efficiently than you can with something like a regular virtualization solution like VMware, for example. Apart from that, Docker also helps with running things locally, easily setting up development environments, that sort of thing. Moving up the stack a little bit, you see companies like HashiCorp, which do a lot of interesting things there. They were the guys who originally created Vagrant. Currently, they are very well known for tools like Console, for example. Console is very much in the same space as some of the Netflix technology that I will be discussing in this presentation. They recently released some other products as well. Most of it is at least free for use, so definitely worth checking out if you're interested in this space. And obviously, one of the things that we'll be discussing in this webinar is what Netflix has been doing and has been open sourcing as a result. Netflix itself is obviously not really a software company. They are an online video company, but in practice what that means is that they build their own software platform for that. And a lot of the things that they came up with and that have been battle tested in production have been open sourced by them for others like you and me to use in their applications. Also, where new solutions are coming up, you also see new patterns in architecture emerging. One of the things I'd like to quickly mention there is the Axon framework. This is something that is an open source framework developed by Trifork for CQRS and event sourcing applications, and especially working with events is something that turns out to be quite a natural fit to microservices, because you can easily propagate events and have multiple services acting on those events all by themselves and simply deal with the things they're interested in. It's very much an integration messaging type of approach. So what you will find as you start building these new applications that need to call out to other services that you have built and deployed, you will see that you will have the need for things like distributed configuration. So that means that if you have multiple instances of the same application running on multiple servers, you probably don't want all of those applications to have their own properties file deployed locally on the file system, because that makes it very hard to make changes that will automatically propagate to all of those applications, right? So that configuration should be somewhere that you can actually share it with. And this is not only true for configuration for multiple instances of the same application. The same applies if you have shared configuration across multiple services, different services. Also, making actual service calls is something that that needs to be managed, right, in order to create a robust system that will be able to deal with failure or what's oftentimes even worse, with partial failure of other services or becoming really slow, for example. You need to make sure that you do not make any assumptions on networks and services simply always being available. You need to be able to discover where services live, etc., etc. So once you start building this, you will quickly realize that even though there are a lot of products and technologies in the space that can help you out, they are basically doing the same type of things. And to help you have a framework to deal with these problems and to come up with common abstractions, Spring actually created a set of projects, which is why I've mentioned the umbrella project term here, called Spring Cloud. Now, in this presentation, we're going to focus basically on the first two bullets on this slide. We're going to look at the Spring Cloud config server and at the Spring Cloud Netflix integration. You can see some other projects that are included in the Spring Cloud family as well here. I will not cover those, but you can look them up for yourself. Basically, everything that you see here is already released in a production version. They use a release train schedule at Spring Cloud, and this is basically called the Angel release. I think they're currently at their third service release or something like that. So this is considered production ready. Currently, they're working on the second major release train, which is called Brixton, currently at its third milestone, which was 1 or 2 weeks ago, I think, was released. And you can see a lot of new projects in here. Some of those projects are actually for specific platforms like the Cloud Foundry solution, if you want to deploy to Pivotal Cloud Foundry platform as a service. And some of them are reworked existing projects like the Spring Cloud Dataflow, which is basically the former Spring XD abstraction, which allows you to build batch jobs with Hadoop and integrate with those types of technologies. But there are some new things in there as well. Console from HashiCorp, which I mentioned on one of the earlier slides, is supported in there. And they also have some, I think, very interesting new projects like Sleuth, if that's the actual pronunciation. which will allow you to do tracing of requests basically as they are entering your microservices-based system and cause all types of fan-out calls. So you can basically see if you're handling a single user-based request and that causes all sorts of services to be called, that this is all on behalf of that single call for tracing and logging purposes, basically. So definitely something to check out. But for now, I would like to spend a little time on explaining one of those projects, namely the Spring Cloud config server. And this is actually easiest to explain by simply using it. So what I'm going to do is I'm going to show you a little project that I've created. We will make sure that once we publish the presentation here online, that we'll accompany it with something like a blog post that will also include the source code for this, so you will be able to look at this yourself. What I have here is a set of projects. Some of them are the custom application that I'm about to demonstrate, but you can also see a project here called config server. What this uses is a dependency of the Spring Cloud project called the Spring Cloud config server starter. And that comes with a very simple annotation called enable config server. If you put that on your Spring Boot based application, basically it will start up a configuration server that will offer RESTful endpoints to allow you to extract common configuration for services. Now, how this is intended to work is that the Spring Cloud config server will be backed by a source code repository, typically something like Git. So if you have a GitLab running, or if you're maybe using GitHub, you can use that to put your configuration files in there in a source-controlled manner that gives you not only a history of your changes, it also allows you to do things like access control on who can make what type of changes. And here in the bottom below my my regular project, you can see that I have a Git repository called Spring MS Demo Config with 3 different properties files. So first of all, there is an application properties here, and every property that you specify in this file will actually be made available to all services connecting to the Spring Cloud config server. So this is good for shared configuration. In this case, the only key that I have in here is the location of my Eureka server that I will be demoing in a moment. And this is something that needs to be accessible to all of the config server clients. Next to that, I have a talk service properties, and this would be a configuration file for a service called the talk service. Currently it's empty, but I'll put some configuration in there in a moment. And finally, you can see that we also have a talk service dev properties. This follows a naming convention that is part of the Spring Cloud config server, where if you are running an application, if you're familiar with Spring, and I assume that most of you are, you can run a Spring application with 1 or more profiles enabled to dynamically determine which Spring beans need to be enabled or disabled. This will actually allow you to have a different configuration or additional configuration on a per profile basis. So let me start up the server and give you a little tour of what this thing can do. As we are starting the server, which is just a boot-based application, you will see it coming up. As I mentioned, it will be backed, and let me show you where that is specified here. It will be backed by a Git repository. Now, in a production setting, this would be some remote repository, like I said, something like GitHub or GitLab. Just for this demo, I've chosen to use the local file system. That means also in this case that the config server will look directly at the files in this directory. If you are using a remote Git server, it will actually perform a clone and it will work on a local copy of that data. That's how it's intended to work. So now this thing is running, we can make HTTP requests to it. And let's say that I have a service, and my service, this is running on port 8000. My service is called some service. And note that there is no dedicated configuration for this. And it's running in a profile, Spring profile, which is simply the default profile. Now this could be a request that an application makes, and what will happen is the config server will come up with all configuration files that match this particular HTTP request, and it will return a JSON document containing all of these so-called property sources that are available to this application. Now in this case there is only one, which is the application.properties, because it's applicable to all services, and it has a single key value pair for the configuration. Now I'll show you in a moment how you can integrate this in a Spring-based application. If you have other applications than Spring-based applications, you could also ask the server to say, well, for this some service default, I simply want to have a properties-based format. This is also supported. This is nice for integrating it with things that are not Spring-based applications. You will just get back a properties-based file. And similarly to properties, and if you're familiar with Spring Boot, you probably knew this already, we also support YAML nowadays. So if you prefer a YAML-based representation of the same configuration, you can do that as well. So normally how you would use this is you would integrate this directly into a Spring config-based application. So with that, let me introduce the first service. We have a talk service here, and this thing is just a little demo app that serves up webinar talks from an in-memory database. And to do that, it exposes a Spring MVC controller, and that has, in this case, a repository that will allow you to see all talks or a particular talk. Now let's say that I want this service to get its configuration from this configuration service. The first thing that we need to do then is we need to add a dependency here, and the dependency will be on the Spring Cloud Starter for config. So this is a typical Buddhism. What you see here is we have a starter project that will automatically inject some dependencies as well as auto configuration, and basically this is all I need to do for my application. Now there is one thing you need to know. If you're using a Spring Cloud-based application on top of Spring Boot, there is a configuration called bootstrap.properties or bootstrap.yaml, if that's the format that you're preferring. For this service, what we can see is that it will advertise itself as a service called talk service, and we also need to tell it where it can find our config server. Now in a production system, like some platform as a service, this would typically be configured through something like an environment property, which could be called config server URL. Here I have a default, which is actually the local host based config server that I'm running at the moment. So with this, we can now start up this application, but you won't actually see much because there is not much configuration for it yet. I will do two things. First of all, back in this configuration file, I'm going to show you that one of the things I can do is I can enable a certain profile, in this case a dev profile. So we should get both the regular configuration as well as the development specific configuration for this service. The other thing I'm going to do is I'm going to show you how we can actually use a configured value. So let's start by configuring that actual value. Going into the talk service of properties, which is currently still empty, we're going to add a key called greeting, and the value of that will be welcome to the Try4 webinar. I can commit this like that, and now my configuration value is in place. Going back to the controller here, what we could now do is say we want to have a string, and we'll call it greeting, and the value of that string should come from the configuration property that we just added. So that would be greeting in our case. To expose this value so that I can actually show you that it works, I'm going to add a request mapping to let's say /greeting, and we'll put that on a method called greet, which returns the greeting that we just configured. Right? Very basic Spring MVC stuff here. Let me start up the application then. What will happen is it will bootstrap an in-memory database with 3 different talks that I have hard-coded just for the demo. And once it's running, I will show you that I should now be able to see the configuration value that it got out of the configuration server. To prepare that, I will already start typing the command here. So this thing is running on port 8881, and the controller is running on /talk, and I added a path mapping there of /greeting or greet. Let me quickly check. Yes, greeting. Application has started up. So what we can do now is we can make the request, and what we should be seeing is welcome to the Trifork webinar. If we go back, and I'll make this a little bit bigger for you to read, and we scroll up a bit, then you can also see at startup that the application is actively telling us that it's fetching its configuration from the server. This is done by Spring Cloud through a separate context. You may be wondering how you actually know at runtime what configuration your application is actually using. If it has remote property sources, it might have some local configuration as well. If you're using the Spring Boot actuator endpoints, as they're called, what you can do is you can just go to the endpoint called /env, which shows your environment, and this will actually give you all of the information that you need. So what we see here is that we're getting the configuration that's for all applications, then we're getting the configuration specific to the talk service, and eventually we're also getting the configuration that is specific to the talk service running in dev profile mode, right? This is the actuator itself. The endpoints are very useful in general, right? You can also see that we have an application properties and bootstrap properties running here. So this will give you a complete overview of what your application is doing. Now, so far, I've showed you something that is basically standard Spring dependency injection. It happens when you start up the application, and then that's it. So if I would now make a change to my property, the application obviously is not automatically going to reflect that change until you restart it. To have an option of actually updating your configured values while the application is running, Spring Cloud also introduces a notion of a refresh scope. So I just added the add refresh scope annotation on the talk controller. If I click through on this refresh scope, you will see it's basically just a type safe shorthand for saying I want to have a bean scope of refresh. And this refresh scope is implemented by Spring Cloud. What it will basically do is create a proxy that will have a target bean that is reloaded automatically whenever you tell it to update the configuration of the application. So with this in place, let me quickly restart the service and show you the effect of adding this refresh scope to the controller class. What we will do is we will first make the call again as I was just showing you. Then we will change the configuration value in the config server. That itself is not yet automatically going to trigger an update of the application, but then I'll show you how we can force the application to reload its configuration and apply the changes without the need for a complete restart. So the application is starting up, and while it is, let me verify that it works by, there we go, making the call to /talk/greeting again. We should once again see the same. Let's do it again. There we go. Welcome to the Trifork webinar. Going back to my configuration of the talk service here, let's say welcome again. I could commit this, and technically I should, but I'm going to take a shortcut here because my Git repository is running on the file system. This will actually be sufficient. If I now call the same URL again, we don't see the updated value yet, which makes sense. The application doesn't know that this value changed in the config server. What we can do now is we can post to a new endpoint that's being exposed for this application called /refresh. And by simply doing an empty post to that, we are telling the application, go check if there is any new configuration, and if so, automatically refresh all of the beans in refresh scope. What this thing will report back as it finds its new configuration are the keys that have in fact changed on the config server side. So what I'm expecting to be seeing in a moment is that we get back the key greeting, because the greeting key has changed, and internally what the application will do is it will reinitialize the controller bean so that we're having the new value applied. Right, so this is the response. We can see that the greeting key was apparently changed, and by making the same request again, we now see welcome again to the Trifork webinar. So that concludes my little overview of the Spring Cloud config server. There's a lot more actually there that we simply do not have time to go into right now. For example, there is support for encrypting, decrypting properties if you want to have configuration properties that not everyone with access to the Git server should be allowed to see. You can have multiple Git repositories backing the same config server. There is support for working with Git branches and tags, etc., etc. So check out the reference documentation if you're interested in all of that. Moving on to the Netflix stack. Netflix has open sourced a lot of its internal projects, and those projects apply both to how you develop Java-based applications as well as how you manage your runtime operations. One of the most well-known projects, I would say, is called Hystrix. This is a project that will allow you to make resilient calls to other services. By resilient, I mean you will be able to deal with full or partial failure of those services without compromising your own services or applications. Thereby keeping the system up and running if parts of the system are not okay. Then there is something called Eureka. This is a services registry that I will show you in a moment, where services can register and can discover the location of other services, and typically there will be multiple instances of those services, so it will find all available instances there. There is also something that I will not discuss in this webinar called RxJava. This is a Java implementation of the reactive extensions, and there are quite a number of implementations of this framework out there nowadays. But Netflix has contributed tremendously to this. This is very interesting if you're building applications that are doing things like fan-out calls, where we need to make multiple calls to different backend services, collect the results, and come back in a single call. This will actually allow you to do that in a very efficient, non-blocking manner. And this will also be something that is the focus actually of Spring 5 that's currently being developed. There is Zool. Again, I probably won't have time in this webinar to go into details, but it allows you to dynamically build proxies. So if you want to expose a multitude of microservices, let's say to an AngularJS JavaScript-based application through a single front end, something like Zool will allow you to do that very easily. And something I wanted to mention, which is not so much in the area of application development, is Spinnaker. This is a really recent addition to the Netflix portfolio. They actually partnered with this with companies like Google to make this available, and this is very much about the runtime operation of your microservices deployed to a cloud environment, and actually multiple clouds, even though Netflix at the moment is using AWS exclusively. Now, to kick off, what I'm going to do is I'm going to show you two particular projects from the Netflix stack, one being Eureka, the service discovery registry that I mentioned, and the other one being Ribbon, which is a client-side load balancer. And I'm going to show you how Spring Cloud supports these two projects. Now, to start off with Eureka, actually, the way that you can start a Eureka server is very similar to what we just saw with the config server. So there is an enable Eureka server annotation if you add the appropriate dependencies to your Maven POM in this case. And what this will do is it will start up a single node, in my case, Eureka instance. I won't go over all of the details of the configuration, but what I will show you here is that I've actually set some properties that you should never set in production because I'm going to run this thing as a single node instance. Now, obviously, a component like a service discovery registry would be pretty central to your whole architecture. So this is something that needs to be highly available. You should have multiple instances of something like Eureka running. And if you do that, they will automatically find each other and work together. I'm not going to do that, so I have configured some things to make sure that even though it doesn't like it, Eureka will still run okay if you only run it as a single node. Now, what we can see is that my Eureka node is also getting its configuration from my config server. That's a common pattern that you can use, and this means that applications will need to know where to find Spring config server, and then from there on out they can find out where to find Eureka. If you want to, you could also do it the other way around. You could say every application knows how to talk to Eureka, and from that service registry they will then be able to discover where the Spring config server lives. So both of those setups are actually supported. Now, when Eureka has started up, it will expose a dashboard that you see over here. And the big red letters are warnings that this thing is running in a way that should not be done on production, but we know that. And we're seeing that currently no instances have been made available. So nothing has registered itself as a service with Eureka, which makes sense because we didn't do anything there. So for starters, let me show you how you can update your service to register itself as a service with Eureka. Now for this, we're going back into the dependencies again, and next to the starter configuration, we're going to add a dependency on something called Spring Cloud Starter Eureka. In this case, just adding the dependency is not quite sufficient. We need to tell the application that we want it to register itself, and also that it can act as a client to the service registry, so that it can find out about the applications and the services that have already been added there. Now, I could add an annotation here to say I want to enable a Eureka client. In that case, I will have something that is really specifically tied to Eureka. But actually, this is quite a common pattern, right? I might want to use something like HashiCorp's console rather than Eureka in production. So therefore, the Spring Cloud project actually exposes an enable discovery client annotation instead, which is more generic in nature, and it simply uses the Spring Boot auto configuration features to discover what I have, and when it finds out that apparently I'm using a Eureka client, it will know, okay, then I want this application to connect to Eureka. Now, what I'm going to do next is I'm going to restart my application first of all, so that it will subscribe to the Eureka instance, and I'm going to start a second instance of that same service that will expose a number of webinar talks, so that I have two instances registered with the same Eureka. But normally, by the way, if you would try this yourself running on localhost, you would have an issue, because Eureka will think that if you have two applications that have the same name and they're running on the same server, they must be the same instance. But I've used a system property here in my run configuration to make sure that that doesn't happen. You can see it over here. I will put this in the blog so you can read all about this later on, or you can look this up in the reference documentation. In the meantime, I have another service. I'm not going to show you all of the code because it's a same trivial type of service as my talk service, but this one will serve up reviews for talks that have been published online already. This one has already been configured to use the discovery client, as you can see here. Also a nice little trick, or no, actually I'll show you that one in a moment. So let me first start up the review app here as well. This will also end up in Eureka. And then finally, as we're having two services now, we need a client for those services. So for that, I've introduced a little web application called the Conference Web Application, so you can make up conferences out of multiple talks or webinars that you have published. What this one will do is it will offer just a simple web interface, and internally it uses something called a talk service, and the talk service in turn uses a REST template to communicate with our talks microservice. Similarly, there is a review service that talks to the review service that I just configured. Now, there is a problem with this code, because if you look at what it does, is it's hard-coded to talk to my one talk instance running on localhost. Now, apart from the fact that you should obviously never hard-code this, it doesn't really make sense in a microservices architecture to put this in a properties file either, because this instance of this talk service could be running anywhere. And I might not just have a single instance running, I might have multiple instances running, and I want to do load balancing. And this is where Ribbon comes in. So Ribbon is another project from the from the Netflix open source stack, and it's integrated by Spring Cloud into the Spring REST template. But in order to do that, I should not instantiate my own REST template, as the code is currently doing. I simply should have the REST template injected. So I'm going to add it here as a constructor parameter. And even though this would already work out of the box, let me make it very explicit here that I'm not asking for just any REST template. I'm asking for the REST template that will be configured by Spring Cloud to use the Ribbon client underneath. And Ribbon, in turn, is going to use Eureka to find out about the services that I'm running. So what this will allow me to do is to replace the host name and port number here with just a logical service name. So I can connect to my talk service without needing to know or care how many instances there are and where they live at the moment. So without further ado, let me start up this application as well, and let me demonstrate you the result. Interesting thing to note is that on this particular Boot Cloud application, you don't see the Spring Boot application annotation, you see a Spring Cloud application. This is just a shortcut, really. If you look at what this annotation does, it's a combination of three things. It's giving you a boot application that will automatically use, in my case, Eureka as a discovery client, and it enables something that I'll discuss next up, namely circuit breakers there as well. So I think the application has started up. Let me first check back on my Eureka dashboard now. So what you can see is that I have 2 instances of the talk service running, and I have my review instance running, so that's all looking good. The conference web application will discover these services through Eureka, and as it does that, hopefully it will make its user interface available here then on localhost 8080. And what we see now is that we are in fact seeing the talks. Here is the talk that I'm currently giving, booting your microservices architecture with Spring and Netflix. Clicking through on that, it will provide me with a bit more detail and the reviews, but obviously there are no reviews for this talk yet. So this is basically how it works. Now, going back to my console window here, and again, I'm going to make this a bit bigger. What I want to show you is that already we are getting load balancing in place right now. So if I empty out the console for both of the talk application instances that I have running, I'm going to press refresh now a couple of times, and nothing interesting to see there, but I will do it 4 times. So that's 1, 2, 3, 4. And if I now go back, you can see that there are 2 requests that have been sent to my second instance, resulting in some logging output, and you can similarly see that there are 2 requests made to the other application instance. So I'm automatically getting load balancing across all of the available service instances. To round off, let me stop one of those instances here and show you what happens now, because even though Ribbon will automatically give me load balancing, it is not going to provide me with failover out of the box. So if I refresh right now, it so happens to be that Ribbon has chosen the second instance to route my call to, and I'm getting an exception, in this case, that there is a connection exception. If I refresh again, because of the load balancing, it will go back to my first service instance, which is available. But if I refresh again, because of the load balancing, it will go to the service that is currently not available. So obviously, that's something that we need to prevent from happening. So with that, let me get back to the presentation and talk a little bit about another component in the Netflix stack called Hystrix. Now, Hystrix is about making service calls in a way that is robust and resilient. And one of the most well-known patterns in there is something called circuit breakers. So a circuit breaker pattern is something that was described in a book called Release It, very much worth reading, by the way. And the idea behind the circuit breaker is just like with an electrical circuit, that if something goes wrong and you're short-circuiting it, you don't want all of the machinery hooked up to that circuit to just crash and burn. What you want to do is you want to trip a circuit breaker that will prevent that local failure from taking down the rest of your network, basically. And this is exactly the same thing that the circuit breaker pattern allows you to do in a distributed application. The circuit breaker will control access typically to remote services, although you could use the same pattern for other things as well. And it will keep track of failures. And if you are getting too many failures in a short period of time, and obviously all of these things are configurable, it will trip and it will simply prevent you from trying to call out to some external system the next time that you make a call to it. Immediately saying, I'm sorry, this service is currently not available, so don't even bother trying it. And it will not only do that, it will also allow you to configure a fallback option. So you could try another service instead, or maybe you could just have some locally cached data that you serve up instead. But at least this will make sure that your application doesn't continuously try to call services that are currently not up and running. Also, it will prevent your application from, when those services are coming back up and running, from immediately overloading them with all sorts of batch stop requests, because you will have handled requests already through a fallback. Now let me show you how we could introduce this concept into our application. So currently, this is the way that we are calling out to our microservice. We are doing a REST template call, and that's it. What we want to do is we want to create a fallback for this. So what I will do is I will assign the result of the method call that I just showed you here to a local instance variable, which, just because this talk will be published online, I'm going to make volatile. And then we're going to introduce a fallback method. And the way that I'm going to show you how Hystrix works is I'm going to use a project called Javanica, which has annotation-based declarative support for Hystrix commands. because Hystrix is actually an API that you program to. But what I'm going to do is I'm simply going to create a new method with the same signature as the actual method, except for the removing the public here. And what this thing will do is it's going to say logger.info returning, returning cached calls. And what it will do then is simply return the talks that I had already. Should also make sure that this thing is actually initialized in case there is no service to begin with, like that. So the only thing left now is to indicate that we want to use Hystrix to use that other method as a fallback, and for that we're going to use Hystrix command annotation. So this is not from Spring Cloud, like I said, this is from a project called Javanica, but Spring Cloud will actually support it to be used in your Spring-based applications like this. And you can see there is a fallback method here. So what I'm going to do is I'm going to say I want to call my cached talks method in case the current method fails to run successfully, right? In order to make this work, obviously, I need to restart my conference application, so let's do just that. In the meantime, I'm quickly going to check the state here in Eureka. Because one thing that I quickly like to mention is Eureka is not intended to give you a fully up-to-date, by the millisecond overview of the state of your services. Services are sending heartbeats to Eureka, and it will take a couple of heartbeat misses for Eureka to understand that the service is no longer there. And then clients will also need some time to actually find out, talking to Eureka, that their local cache of where services are and what services are available is no longer valid. So it can take up to, like, say, 1.5 or 2 minutes for your application to eventually find out, oh, this other service that I was talking to is no longer there, right? So therefore, it's important to have something like Hystrix in place, even if you are having a service registry that will tell your applications what services are available. So I've restarted my application. Currently, it should have found out that there is only a single talk service instance that it's currently talking to. So making a couple of requests here and going into my log, you can see that I'm returning the latest calls here. So that's good. What I'm going to do now is I'm going to stop the last running instance of my talk-based service, and I'm going to make a couple of more calls here. And as I'm refreshing, you can see that there is no error in the browser. But as I'm going back to the local console here, you can see that currently I am actually triggering cache calls to be returned. And I can start my talk application back up, and as soon as it becomes available, we should see that we're now doing that. Now, with this in place, obviously it becomes very interesting to monitor the status of all of these circuit breakers. And one of the nice things is that there is actually a standard endpoint running. So my application is on port 8080, and it exposes an endpoint called hystrix.stream that will continuously send a stream of events showing the state of all of my circuit breakers. Now, I'm just showing you so that you know it exists, but this is obviously not data that you will want to interpret yourself. And there is a nice application for this that will just visualize the state broadcasted through this Hystrix streams. That's called the Hystrix dashboard application. Now, in a similar fashion to the config and Eureka server, there is an @enable Hystrix dashboard annotation that you can use to quickly get an application like this up and running. So I'm going to start it up. And once this thing is running, I'll show you that we can use this to inspect the state of the circuit breakers living in a particular application. For that, I'm going to open up a new tab. And once the application has started, we will see in just a second a user interface here, and this will allow me to enter the particular stream URL as I just typed it in of one application. Obviously this doesn't scale, right? If you have a lot of services, you want to monitor all of them, not one particular server. There is another application for that called Turbine. I'm not going to demo it because I don't need it for this particular demo, but basically that would give you this a similar dashboard as what I'm about to show you here across many different services. Now, right now, I'm looking at just my my conference application, and we can see that there is a single circuit breaker called All Talks, and currently it's closed. Right. So let's put some load on the service, and I'm going to use a tool for that, command line tool called Apache Bench, or AB for short, and say for 10 seconds I'd like to make some requests to localhost 8080. So what you'll see is that on the left-hand side in the web application, we can see that the load is currently up. We can see how many requests are being handled per second, and there's a nice graph there as well. In the command line, we can see that all calls were made successfully, so we have 0 failed requests. What I can do now, and I'm going to increase this to 20 seconds for that, is while I'm running AB, I'm actually going to stop my doc application again. So switching back now to the dashboard, we should see that in a moment's time, there's going to be a problem with one of my backing services. So the circuit breaker will trip, and you can see that the state is currently changing. So this will give you information on if circuit breakers are tripping or not, and if there are failures in your application. Now going back to the command line, you can see that there were still 0 failed requests, right? So this is exactly what the behavior that we're after when we're using circuit breakers. Even though there was a problem with one of the components in our architecture, the end user, or the client in this case, doesn't actually notice that because it will simply get the result of the fallback being applied. That's pretty much what I want to show you for that. Now, even though most people think of Hystrix as the circuit breaker library, there's actually an interesting tweet here from Ben Christensen. He was one of the lead architects of Hystrix, of Netflix in general, before he moved to Facebook. And he's saying here that actually circuit breakers are overrated and are not really the most important thing in Hystrix, because at least for Netflix purposes, there is another feature in Hystrix, which he refers to as bulk heading here, which is actually considered to be more important. So what's bulk heading? Well, as you can see here already in the tweet, bulk heading is about concurrency limits. So where does this term come from? Well, basically it comes from building ships where you don't want a single leak in a ship to just flood the whole ship and sink it. So what you want to do instead is you want to compartmentize that, and whenever there is a leak, it will only flood a part of the ship, but everything else will just stay intact and keep the ship afloat. Basically what we want to do is achieve the same thing in an architecture where if one component starts misbehaving, it shouldn't drag everything down with it, right? The problem should be contained and it should remain local. And one of the ways to achieve that is to make sure that whenever you're running something with a Hystrix command, is to make sure that those Hystrix commands run on threads from a dedicated thread pool. That thread pool will be configured specifically for the command that you are using. So this will make sure, for example, that we can never make more than a certain amount of parallel requests to a certain microservice. So whenever our application is being flooded with too many requests, more than we actually can handle as a platform or as a system, we are simply going to fail certain requests rather than trying to push them all down to the microservices that are sitting behind our application, causing problems on their part as well. So how does this work? Well, actually, this is already in place automatically. If you go back to the monitor, you can see here that under the circuits, there's also a thread pools here. And by default, I'm going to have a pool size, of 10 threads in this thread pool for this particular circuit breaker, and a queue size of 5. So that means I will be able to make up to 10 parallel requests, and every thread will be able to queue up 5 requests before it simply says I can no longer take this, and we're going to not make the request at all. So I can demonstrate this a little bit as well. Let me first check if I still have the talk app running. No, I'm going to restart that. So what we can do is we can use the AB command again, but this time we're going to increase the concurrency to 10 requests. And as we're doing that and we're monitoring it, in this case, because I hadn't started the talk app yet, the conference app thinks it's not available because it hasn't found the new service instance yet through Eureka. So it's going to use its fallback for every request that I'm making. But since I'm using 10 parallel requests, that should actually still be okay. So going back here, we can see that we have still 0 failed requests, right? What I'm going to do now is I'm going to increase this concurrency a bit, and I'm going to set it to 12. And this time, we should see requests failing, because what happens now is that even though we're using the fallback, that's not interesting in this case, because before checking if we can call the service or need to call the fallback, Hystrix is first going to check, do I even have a thread available for handling this particular request. And if it says I have too many threads already doing this, I'm just going to deny the request. So what we're seeing is that we're actually getting back a fair number of failed requests from the Apache Bench tool here, because the application simply refuses to handle the request because it says I have no more threads available. Now you can tune this if you want to, and through Javanica you can do that in an annotated fashion. I'll quickly show you how to do that, although I won't demonstrate the results. If we go back to this, then there is another attribute that you can set on this annotation, which is called thread pool properties. And through the thread pool properties, you could say I would like to have a hystrix property, and the name of that hystrix property would be the core size in this case, and the default value for that is 10, as we have seen in the application, but we could set it to something like 20 and then increase the thread pool by that. Now, you should be wary of doing this. Actually, from what I've seen, Netflix itself is using the default size of 10 for the majority of its own circuit breakers and hystrix commands. They have a number of use cases for which I do need to increase it to something like 25, 30 maybe, but it should be a rare occasion that you actually need more than that. Right, so this gives you not only the ability to fall back on errors, but also to prevent problems in one application from cascading to the underlying applications as well, and thereby bringing down your application. There are some other things you can do with hystrix that I won't go into detail on. But there's integration, for example, with the RxJava that I mentioned before for doing things in a non-blocking fashion. You can also make sure that if you're making a lot of consecutive requests to the same microservice, that you can actually collapse them into a single batch request, and this can improve your latency tremendously by just batching up calls and doing a more coarse-grained call rather than a whole bunch of small fine-grained calls. There are some nice examples out for this out on the internet if you Google for that as well. So, to conclude, what we've seen is that when you are moving towards a more distributed or microservices-based architecture, that doesn't only mean that you have to think about things like automating your deployments and doing operational things. It also means that this will affect the architecture of your applications, bringing in new patterns, new challenges, and through something like Spring Cloud, also new abstractions to help you to fight all of the boilerplate that is involved with wrapping all of your calls in things like circuit breakers, finding out about configuration, etc., etc. Now, I should stress that this demo has really just showed you the tip of the iceberg. It's just 2 projects that I've demonstrated here. There's lots of other stuff that is very interesting that's currently being developed. You can find a lot of information on all of that functionality, obviously online. For starters, I would check out the Spring Cloud reference documentation and samples that go with that. Netflix itself has a nice website on everything that they offer on GitHub, where they publish all of their open source software. If you're interested in the architecture of, let's say, cloud-native applications or applications that are suitable for being deployed in such an environment, you should check out something called the 12-Factor app. This is basically a set of patterns or recommendations published by Heroku originally on how you can build applications that behave nicely as citizens in a cloud-based environment, basically. Also, an introduction on some of the topics that I mentioned here, but a little broader than that even. You can Google for a new free O'Reilly ebook from Matt Stein, who works for Pivotal, called Migrating to Cloud Native Application Architecture, and obviously there's lots and lots of information out there. Also, I should note that next year on the GoTo conference, which is organized by Trifork, we will have an entire track on Advanced Spring, and there will be several talks actually there on Spring Cloud. So with that, we come to the end of the webinar. I hope you enjoyed the talk. If you have posed any questions, then Liska will pick some of them that I will try to answer right now. If you have any additional questions later on, or if we run out of time for that, we can take that offline, and you see some contact details here that I will leave on the screen for ways that you can contact me or Trifork in general. So thank you very much for your time.
Thank you, Joris, for your excellent presentation. We have a couple of questions coming up. I would like to announce that if you want to meet Joris, you could join our training program that Joris is giving as a trainer for Core Spring, Spring Enterprise, and Spring Web. So